and I live in Tokyo 30% of the time, and for the rest of the time, I'm traveling. Like here, I was in the US, I'll be in the US in 2 weeks. So it's all about traveling and giving talks at conferences. I enjoy games. My favorite games are like City Skylines and Factorio, if you know the games. That'd be awesome. I enjoy eating delicious food. It's great to be in Taipei because there are a lot of great restaurants here. I'm practicing Chinese a little bit. 大家好，我的名字艾玛，我学习中文。That's everything I remembered. But thank you. Okay. Before going to Kubernetes and the 12-factor applications, I'd like to talk a little bit about containers. Not the ship containers, however, software containers. This is a little bit smaller. I'm sorry about that, but from the left-hand side to the right-hand side, there is a dedicated server, virtual machine, and a container. Once upon a time, there was only physical servers. Everything was on the real servers, and software and hardware was tightly coupled. So in order to set up and deploy applications, it's all about deploying hardware, installing operating systems, and installing applications and the dependent libraries on top of that. So if there was a hardware failure, you had to reinstall everything from scratch. It was hard. And then some smart people invented virtual machines. It was to decouple software and the underlying hardware. So once you have a virtual machine images, you can move the image from one server to another, or if there is a hardware failure, you can still migrate the operating system to another server and keep it running. But there was a downside. Virtual machines were slower. So another group of smart people invented containers. Containers push the boundary between applications and hardware a little bit towards the application side. And instead of virtualizing everything, containers packaged application code and dependency libraries like Rails, Ruby, and any other libraries, so that you can move container images from one operating system to another, or deploy to multiple servers. And containers are good because it's fast. It's faster than virtualizations. And containers are, in fact, just processes like regular Linux processes. So it boots up in milliseconds instead of minutes for virtual machines. And the images are portable. You can move container images from Linux to, for example, Mac or Windows servers if they have the same container engine running. And it's very efficient at the same time. So efficiency is not only about speed, but also about memory consumption and other resource consumptions. In the case of virtual machines, you need to have the operating system disk images for every guest operating systems. But with containers, you only need the application code. So this is very important for large-scale environments. And containerizing Rails application is kind of straightforward. This is a Docker file for a hello world Rails application. And this is small, but the first 5 or 6 lines are all about installing dependent libraries with apt. And the rest 10 or 6 or 7 lines are all about like copying application code to the container library. This is almost a copy-paste from a reference manual. So this is easy, but what if you have more than one servers? You don't want to SSH into each of the servers and deploy and copy container images. Instead, you need some kind of tool to manage your own servers. And a lot of companies and software engineers try to solve this problem. And Google is one of them because Google had a lot of servers back then. And they created a system called Borg, but I'm not going to talk about Borg today. Instead, they developed Kubernetes. So Kubernetes is almost an open source version of Borg. So instead of publishing Borg, because it's too tightly coupled to other infrastructure within Google, they decided to build it from scratch. Kubernetes means pilot or a helmsman of a ship. It's a Greek word. Somehow, like a lot of container-related projects and technologies decided to use Greek words. It's really hard to pronounce Kubernetes in a correct way, but it's basically about pilot. Like it's for like operating ship of containers. And it has attracted a lot of developers and users. There are more than 60,000 commits and 1,600 contributors from a lot of different companies. It's not about Google anymore. It's there from Red Hat, IBM, Huawei, Intel, and a lot of other companies. And this is one of the most popular projects on GitHub. And we have a comic about Kubernetes, and I have stickers for you if you want to learn more about Kubernetes specifically. And I'm giving this talk on behalf of Athena, goddess of wisdom, craft, and containerized applications. So if you want to learn more about Kubernetes, I have stickers. It has the address, the link to the comic. But let me briefly explain the overview of Kubernetes. This is a very high-level illustration of the software. You have nodes, the blue ones, pods, this is not a pointer. The red ones, and containers, the green squares, and Kubernetes manages them all. Nodes are logical servers on computing resources. They can be physical machines or virtual machines, any kind of computation resources. On a single node, there could be one or more containers. And more importantly, nodes can be added or removed from a cluster at any time without turning down the cluster. So you can scale up, scale out, and scale in a Kubernetes cluster anytime. And this green box is a container. This can be a Docker container process or any other kind of container like application processes. So this is the actual application or middleware like Nginx. And with Kubernetes, you can use Docker or different kind of container management engines like Rocket, LXC, and others. And pods. So containers are the actual processes, and nodes are like logical servers. But sometimes you want to group defines multiple containers in one execution context. For example, a Rails application might want to run another command line tool in the same source tree instead of a different disk image. Right? So a pod is to group multiple containers and associate them with a network address and storage and other resources. In one pod, you can have one container or more than one containers. So looking back at the picture, notice these blue boxes are machines, and green small boxes are processes, and these red ones are process groups, or not really process groups, sorry, but process groups is a specific term for Linux, group of containers. And you can have multiple of them. And from user standpoint, you have a load balancer in front of a Kubernetes cluster, and you have multiple pods depending on your workload. And Kubernetes manages the load balancer and pods. So in order to scale out, you need to increase the number of pods, or instead of scaling, decrease the number of pods. And now the 12-factor applications. Have you heard of the 12-factor? Or like, have you seriously reviewed each of the items? I actually hadn't until recently. This is a set of the best practices of web application development, originally proposed by Haruka. Haruka is a cloud service provider, which is really, really nice to run Rails and Ruby applications. And also Haruka used this principle to develop their own applications. So this is kind of a proven and the common sense principle and guidelines for web applications. And the 12 factors source code is published under the Haruka user on GitHub, so you can check it out if you're interested in learning more. And these are the 12 factors. I apologize, these Chinese characters are simplified versions, not the traditional ones. But I think it makes a little more sense. And if you look at these 12 items at the same time, they might look a bit scary and overwhelming. But actually, some of them are very easy and straightforward. Let's take a look at the first two items. The code base. The first principle, code base, is all about managing your code base. Instead of developing with zip and folders, use Git or Subversion or any other kind of source revision control if you're developing some serious applications, which is something you already do, I think. And the second item, dependencies or dependency management, is all about to ensure that all the required items are explicitly defined in some kind of file or data. For example, if you use Ruby and Rails, you use a gem file to list all of the dependencies, and this is also something you already do for your Rails applications. So these 12 items are not something very difficult and sophisticated. This is from the very basic principles to more about common sense practices. And if you use Rails, because Rails is older than this 12-factor app. This 12-factor app, the items are actually based on Rails. Some of them are. Let's take a look at these 3 items: backing services, processes, and port binding. So backing services is about managing database, cache, or external party APIs as separate resources and make them independent from the source code. For example, if you want to connect to multiple databases, instead of hard coding them in your source code, take them treat them as a resource and make them pluggable. This is also something Rails takes care of. Like, for example, if you want to connect to a production database, you write so in database YAML, and Active Record takes care of it. If you want to connect to a development server, database server, if you write so in database.yaml, Rails takes care of the rest. So, great. Processes. Quote, 12-factor processes are stateless and share nothing. Any data that needs to persist must be stored in a stateful backing service, typically a database. So stateless means they can be started and terminated at any time, like Rails applications. You can control C and terminate Rails applications at any time. Share nothing means they don't communicate to each other. Like if you have multiple Rails server processes, they don't communicate to each other, right? And data is stored in database. So this is exactly what a Rails application looks like. So pretty simple. And port binding. Quote, the 12-factor app is completely self-contained and exports HTTP as a service by binding to a port. That means instead of dealing with files and directories, each of the services should communicate with other services through HTTP or TCP ports. This is also how Rails application works. If you launch a Rails application, you access to the Rails application from port 3000. Okay, so we cleared 5 of the 12 items already. So this looks very easy and straightforward. And I'll explain the rest of the items. The rest of the items have a little to do or something to do with Kubernetes. So I'm going to introduce some Kubernetes internals and these principles at the same time. So config, the 12-factor app stores config in environment variables. So configurations, application configurations should be stored outside of code, and so that they are easily modifiable. For example, if you want to change switch from one database to another, you don't want to modify the code and check in again. And Kubernetes exactly support this feature, and you only need to write a YAML file. And by the way, Kubernetes, these configurations are all in YAML file, so this sounds familiar to Ruby developers, right? So if you set an environment variable in the YAML file, Kubernetes automatically applies these variables to all of the clusters and pods, or all of the containers and pods. And secrets and credentials need special attention because they are very sensitive, and you don't want to commit, for example, your cloud provider's API keys to GitHub. They might like mine bitcoins with these keys. If you do, so you need to take care of these credentials. And Kubernetes supports secret management. So instead of storing them in a YAML file, you can update secrets from APIs or command line utilities so that they are stored inside of a Kubernetes cluster. And they can be pulled from pulled as an environment variable or as a file as a virtual file or in a container, and so that they can read from applications. Now, build, release, and run. So this is interesting. When you're developing a web application, the flow of development is always from code to release. What does it mean? So if you have a production bug, you don't log into production services, servers, and edit the source code on the servers and bring them back to source control. You always edit the source code on the development side and commit and build a container image and deploy to servers, not the other way. And each of the releases should be versioned so that you can deploy and roll back at any time. If there is a critical bug in a new release, you can always switch back to an older release and fix the production bug. Kubernetes provides features to support the release and rollback. Kubernetes can deploy applications in a rolling basis, so without interrupting service, you can deploy a new version on a small set of servers and eventually to all servers. And if necessary, you can switch back to an older version at any time. And concurrency. So concurrency is all about scaling out. Since all the processes are share nothing, adding more computational resources is all about launching, forking more processes. This is very important to use multiple machines. So scaling up has a limit. You can't scale up to thousands of processors. You need to scale out to use multiple machines. And scaling out with Kubernetes is easy. You even don't need to worry about memory or CPUs on each of the servers. You only need to specify the number of processes. For example, if you have 3 pods or 3 processes in your cluster, the Kubernetes handles the situation as replicas equals 3. And that means you have 3 copies of the same processes. And if you want to increase it to 4, you only need to specify the replicas. Sorry, I messed up, but this should be 4. If you specify 4, Kubernetes spawns another process and handles the rest. And these pods and processes are scheduled to the least utilized machines, so that the server's resource utilizations are always managed and balanced between servers. 9, disposability. Quote, maximize robustness with faster startup and graceful shutdown. This is about ease of starting a new process and shutting down. And all the processes should terminate when they receive sig term. And so Rails processes are relatively faster to launch. Even if you have the biggest application, they usually start up in seconds, not minutes. And containers, as I said before, just as fast as processes. So no problem if Rails is disposable so as containers. So and on top of that, Kubernetes monitors and watches the life cycle of containers. So if there is anything wrong and containers exit prematurely, Kubernetes try to respawn the processes and try to fix the situation. And 10, dev and production parity. Quote, keep development, staging, and production as similar as possible. So this is important to prevent any production-only bugs. For example, by default, Rails uses SQLite, right, for development. And if you only use Postgres for production and use different SQL servers for development and production, you might get into a serious problem. So you want to use the same database, same configuration, same settings for all the environment you have. Kubernetes supports multiple different kinds of environment for different use cases, and you can use the same configuration files for all of them. And all the configurations can be written in YAML files, so all you need to do is just copying YAML files to different clusters and environments. The three environments of Kubernetes are Minikube, independent cluster, and managed clusters. Minikube is a single node Kubernetes. This is the best way to test and develop on Kubernetes. Installing it is just as simple as a single brew command if you use Homebrew on Mac. It also runs on Windows and Linux, so this is very easy to set up, and it runs on your laptop. And if you want to use Kubernetes on the multiple nodes, you can always install the open source version of Kubernetes and run in your data center. You have full access to all the features, control, and you can use the latest version, not only the released version. You can check out the head version and try that. The downside is, however, you have to manually set it up and manage it. So if you don't want to deal with that, there's a couple of cloud vendors like Google, Amazon, Microsoft. All of them try to provide similar the same set of APIs as Kubernetes, and so that you can use the same configuration and run your Kubernetes cluster in cloud. Google Kubernetes Engine is one of them. It works very well with other Google Cloud features. So if you want to run a Kubernetes cluster in cloud, this might be your choice. So what's important is you can use the same configuration, same software, same code on your laptop, in your data center, and in cloud, so that if your development cycle is in the early stages, you can like write your code on a laptop, deploy it to your own local Kubernetes cluster, and when they are stable enough, you can either deploy to your data center or to cloud. And if something doesn't quite work well, you can always migrate from one environment to another, like from on-premise data centers to cloud, or one cloud vendor to another. We are almost there. 11 logs. This is all about, so this is to simplify application logging. Application logs are not written to files from the application perspective. They are written to a standard out or standard error, so that they're handled separately from the application processes. Rails 5 supports this principle by default and supports logging to standard out, and Kubernetes and Docker handle the rest. So if you have logs coming from standard out, and Docker writes it to a log file on the node, and Kubernetes takes care of the rest, like log rotation and yep. And from the cluster perspective, for example, if you have a Rails app in one pod, you might have a logging agent like FluentD or a Stackdriver in another pod, and the standard output of Rails goes to a log file, and then the logging agent watches the log files and it sends out to log information to a backing server or any other like storage. And last not but least, admin processes. Quote, run admin/management tasks as one of processes in the same context as production applications like Rails DB migrate. So when you run Rails DB migrate, they should run in the same context. You need to run the command in the same source code tree instead in a different storage. So you need to run the command in the same context. And with Kubernetes, you can run a process, an additional process in a pod, or you can start a job so that Kubernetes somehow schedule the job and deploy it to one of the nodes and run it and make sure it runs successfully. And also cron tabs or cron is all supported so that you can run scheduled tasks in a Kubernetes cluster in a safe way. So we covered everything. Seems easy, right? So with Kubernetes, you can run Rails applications respecting the 12 factors. And the 12-factor app is not very hard. They might look terrifying, but actually most of them are easy enough, common sense principles. Sometimes you need exceptions, but most of the times it just makes sense. And as I said, Minikube is as simple as one homebrew command, so you can try it right now on your laptop. And that's my talk. Thank you very much. 谢谢大家。
Thank you, Emma. It's now QA time. Is there anyone wanting to ask a question about? Oh, yeah.
There are a couple of like Docker file definitions and Kubernetes definitions on GitHub. If you search for Rails Kubernetes or Rails Docker, I think you can probably find example configuration files on GitHub and blogs. There are a lot of blog posts about them. You can create a private registry for your close to your cluster, or you can use a public registry like Docker registry, or if you're running Kubernetes in a cloud environment, most of the cloud providers have their own like private registry.
Anyone else? Yes.
What do you mean large, like complex, like longer? So Kubernetes has a good manual, you can find a lot of example configurations in the manual, so you can copy and paste from these manuals. There are a couple of tools to generate YAML files, so you can try them out. Also, Kubernetes supports GUI, so you can review configurations from GUI. The GUI is not quite complete, so there are a lot of configuration missing from the user interface. You need to write the actual YAML file instead of editing from GUI. But I think that's this is still something manageable. I hope this answers your question.
One last question. Okay. So if you have further question, you can ask Emma privately later.
And stickers.
Oh.
And my cards. If
Stickers.
you have any other questions, feel free to email me anytime. Thank you very much.